Okay, this is the end of module review for Unit 1, Grade 8, the integer exponent unit. For number 1, we have 2 to the negative 4. Which of the following is equivalent? Well, if you take this and you have to put it, the reciprocal is 1 over 2 to the 4th, which then equals 1 over 16, which would be B. The next one is what value would be N, so that it would equal 1 over 49. Well, 1 over 49 would then be 1 over 7 to the second power. And when I take that, I could have 7 to the negative 2. So in order for that to be 7 to the negative 2, this N would have to be 0 plus negative 6 plus what value would equal negative 2. That answer would be C, or 4. So the answer there would be C. The last question on this page, which one is not equivalent? We could check all of these. This would be negative 2. And again here, this would be 1 over 6 squared, or 6 to the negative 2. So here we've got also negative 2. Here we have negative 2 as our exponent. This is the only one that is not negative 2. It is 4. So our answer here is D. Next, we have to simplify the following expressions. Write all answers in exponential form. Make sure to show all work. Okay. The only one that you are not going to write in exponential form is number 5, and I will show you why. Here we have negative 4 times 5 and times x to the 2 plus 6. So here we have negative 20 x to the 8th power. Here, because this is addition, okay, we have 3 to the 0 power, or 1 plus 7 to the 9 minus 4, which equals 1 plus 7 to the 5th power. Here we can actually put that in our calculators. So when we put that into our calculators, ladies and gentlemen, we do have an answer for that. So when you put 7 to the 5th in your calculators, ladies and gentlemen, we get 16,000. So 1 plus 16,807 in our calculators, and we actually can add 1 to that. So our actually answer here is 16,808. Now our answer for down here, we have x to the 5th to the 3rd power. So we actually are going to multiply x to the 5th times 3 over x to the 11th, which therefore will be x to the 15th over x to the 11th. So now we have x to the 15 minus 11, which is x to the 4th power. Our next question we have is, which of the following expressions is greater, and show all your work. So here I'm going to take these one at a time because we've got the negative in there. We've got 1 plus negative 4, which is 2 to the negative 3, times 2 to the 2. Adding those together, we have 2 to the negative 1, which at this point is 1 over 2. Here I have 5 plus 2, so we have 2 to the 7th over 2 to the 6th, which that equals 2 to the 7 minus 6, which is 2 to the 1st, or just 2. So the answer to this expression, which one is greater, is expression B. Okay. Next, for number 8 and number 9, I'm going to cross these off, ladies and gentlemen. We're not going to worry about these on the test. Though actually for number 9, we could do. For number 9, 27 is 3 to the 3rd power over 3 to the 2 times 4. This would equal 3 to the 3rd over 3 to the 8th, which would be 3 to the 3 minus 8, which would be 3 to the negative 5, which is 1 over 3 to the 5th. You know how to do this one, okay? I'm not going to say it's not on the test, but something like this you should know how to do, but I don't see where something that it may or may not be on the test. Something like A will definitely not be on the test, okay? Next, all right. Jill writes 2 to the 3rd power times 4 to the 3rd power equals 8 to the 6th power, and the teacher marked it wrong. All right, explain Jill's error, and this is worth 1 point. Okay, her error here, Jill multiplied the bases and added the exponents. She cannot. Add the exponents. Unless the bases are the same. She also cannot multiply the bases. Okay. Next. Find n so that the number sentence below is true. Well, because they all have the same basis, what we can say here is 3 plus n equals 9. Okay. What we said here is 2 to the 3rd times 4 to the 3rd equals 2 to the 3rd times 2 to the n equals 2 to the 9. So because these are the same, I can move it to here because they're the same basis. Subtract 3 from both sides. Can make it a one-step equation. Therefore, n equals 6. Okay. Down here at the bottom. It says you write 7 to the 5th times 7 to the negative 9 equals 7 to the 4th. Kesha challenges you. Prove it. Show directly why your answer is correct without references the laws of exponents for your integers. In other words, don't just add them. Prove it by showing it. And this is how you show this. And this is what I'm going to be looking for. If we take 7 to the 5th times 9 to the negative 9, 7 to the negative 9 power. I can rewrite this as 7 to the 5th power times 1 over 7 to the 9th power. I then can write 7 to the 5th as 1 over 7 to the negative 5th power, and times that by 1 over 7 to the 9th power. Well, if I combine them, I can write it as 1 over 7 to the negative 5th power times 7 to the 9th power. Well, I can add those together, and I can get 1 over 7 to the 4th power. Well, remember, because of our rules, I can then write that as 7 to the negative 4th power. And I just proved that 5 to the 5th times 7 to the negative 9th equals 7 to the negative 4th. That, ladies and gentlemen, concludes our review of the end of the module assessment.